Hello everyone, this is lecturer Renuka Baban Singh and I am going to present a PPT on packet switching. Now what is packet switching? It is a technique of transferring data from transmitter to receiver. If we have to send a longer message from one end to another, then it will be divided into small packets and that will be transmitted individually from source to destination, and at the receiver end all the data arrive at the destination will be recompiled into original message. How it operates: data are transmitted in short packets and the size of that packet is 1000 octets. If a station has a longer message to send, it breaks it up into a series of small packets. Each packet now contains parts of user data and some control information. What is that control information? Control information is actually the destination and source address. The advantages of packet switching. There are some advantages which you can see, that is line efficiency. Single node line efficiency. In line efficiency, single node to node link can be shared by many packets over time. Packets queued and transmitted as fast as possible. Next advantage is data rate conversion. Each station connects to the local node at its own speed. Nodes buffer data if required to equalize rates. And another advantage is packets are accepted even when network is busy. Now, switching techniques. There are two types of switching techniques in packet switching, that is virtual circuit and datagram. What is datagram packet switching? In datagram approach, each packet is treated independently with no reference to packets that have gone before. No connection is set up. Packets can take any practical route. Packets may arrive out of order, packets may go missing, up to receiver to reorder packets and recover from missing packets. More processing time per packet per node. This is somehow looks like packet switching datagram approach. What happens here is, at the transmitter end, a message is split into three small packets that are sent to receiver to destination, and it will use its own link to move from source to destination. At the end, all the data packets are received at the destination and that will be recompiled. Another technique is virtual circuit packet switching. In the virtual circuit approach, a pre-planned route is established before any packets are sent. There is a call set up before the exchange of data. All packets follow the same route and therefore arrive in sequence. Each packets contain a virtual circuit identifier instead of destination address. More setup time, no routing decisions required for each packet, less routing or processing time. The virtual circuit approach looks somehow like this, and a temporary route has been established from source to destination and all packets follow the same route and they will reach at the destination station.